So today we have three little concepts to explore. The first one is testing the difference between two means using z-test. We are still working on hypothesis testing. If you remember in last class, we work on hypothesis testing for one sample. That is, in order to perform the test, we just have one sample. But today, in each problem, you'll see that there are two samples. That's why the first one is testing the difference between two means, that is the mean from two different samples using z-test. Because we are using two different samples, there are a couple of things you need to know. The first one is your sample must be random. Okay, both samples must be random. That is first thing. And in this case, whenever you're using the z-test, the sample standard deviation must be known. The standard deviation of both population must be known. That is another important thing that we must have. And if the sample size is less than 30, then population must be normally distributed. But to use the z-test, the standard deviation must be known. And from the previous class, you know that when we follow the 5 steps, we must have the z statistics in order to calculate the p-value. So the z statistic for the difference of two mean is given by this formula. The formula looks a little crazy, but it's not difficult to use. Z equal to, you can see the mean of first sample minus the mean of second sample, then minus the population mean for the first population and population mean for the second population, all divided by the square root of, as it is mentioned here, standard deviation of both must be known. Standard deviation of first population is squared divided by the first sample size plus the standard deviation of the second divided by the second sample size. So make sure you highlight that in your note catcher because we'll be using that in the example. Here is our example. Example, a professor at university wants to see whether there is a significant difference in the age of resident students and commuting students. He selects a random sample of 50 students from each group. The average age of the resident student is, the first mean is 22.12, and the average of the commuter student, the second mean is 22.56. At alpha equal to 0.05 or 5% significance level, decide if there is enough evidence to reject the claim. We want to reject the claim of no difference in age of two groups. Assume that the population standard deviation for the first one is 3.68 and for the second one is 4.7. Okay, let's begin. There are a lot of information there, but first we are going to collect whatever is given. So whenever you're working on two samples, always remember in your null hypothesis, you must have the equal to sign in null hypothesis, you know that. But here we are talking about the mean. So the equal to sign will be mu1 equal to mu2. That will be your null hypothesis. Always remember, in two sample test, whenever we are writing the null hypothesis, it can be mu1 equal to mu2, or if it is the proportion, then p1 equal to p2. And our evidence here is we want to check or we want to reject the claim of no difference in the age. So your alternate hypothesis is no difference. Meaning of that is mu1 is not equal to mu2. Because in alternate hypothesis, you will have not equal to, greater than, or less than. But here we are talking about no difference, meaning of that is not equal to. And this is our claim. According to the question, this is our claim. Because we want to check, we want to decide if there is enough evidence to reject the claim. We are trying to reject the claim. Can we reject the claim at 5% significance level? So this is the null hypothesis. You know that in first step, we write the hypothesis. This is our hypothesis. And you can see in the hypothesis, you have equal to, not equal to sign. If there is not equal to sign, meaning of that is this is two-tail test. Two-tail test. Make sure we write all these steps. Two-tail test. And also, We are going to collect all the information given here so that it's easy for us to tackle the problem. We have the information about the resident student and the commuting student. So let me write here, resident student and commuting student. We have two group of students, two different sample. And what is done here is he selects a random sample of 50 students from each group, meaning of that is N1 is 50 and N2 is also 50. 50 students from each group. Mean of the first is 22.12 years. The mean age is 22.12. Mean age for the second group is 22.56. Mean age for the second group is 22.56. I'm just writing the information given in the problem. The population standard deviation for the first, sigma 1 is equal to 3.68 and sigma 2 is given here, which is 4.7. 4.7. These are the information given. Now, this is the first step. Now, in second step, what we are going to do is we are going to calculate the test statistic. So in this case, because the population standard deviation are known, we are using the z-test. So z is equal to, if you remember the formula, it was the difference of the mean of the sample minus the difference of the mean of the population divided by, we have to divide this by the square root of population standard deviation of the first divided by sample size n1. Population standard deviation of second is squared divided by the sample size n2. Everything under the square root. Now here, it's the difference of the mean x1 bar minus x2 bar, that is 22.12 minus 22.56. 22.12 minus 22.56, then minus. Now here you have to look at this very carefully. Here we have mu1 minus mu2. You can see here mu1 and mu2 are equal. If we subtract equal quantities, this will be 0. So this is 0. Divided by the square root of sigma 1 is squared, that is 3.68 squared. 3.68 squared divided by n1 is 50 plus sigma 2 is squared, that is 4.7 squared. 4.7 squared divided by 50. So we need to simplify this using calculator. So by simplifying this using calculator, the result should be negative 0.5212. Make sure you check that in your calculator. That's what we'll get. Now, let's try to show this z value or the test value or test statistic in the distribution. This is a two-tail test, meaning of that is your p region is on the tail. On the both tail, you have the p value. So this value plus this value will be p, meaning of that is this is p over 2 and this is p divided by 2, half of p, because the total value is p. And this is z and the equal value on the other side, negative z. So we got this negative z. Negative z is, this is equal to negative 0.5212. Negative 0.5212. Now, if you want to find this area, you can use normal CDF. And when you double this, you'll get your p-value. So if you use normal CDF in your calculator, you can do this, normal CDF, okay, in your calculator, normal CDF. If I want to go on this left end, this is negative infinity, so negative E99. The upper value is the z-score, which is negative 0.5212. Mean is 0, standard deviation is 1. If we calculate this value using TI-84 calculator, if you remember in TI-84 calculator, you have to go to, first you have to go to vars, eh, I mean second vars, okay, second vars, and then number 2, you'll find that normal CDF. And if you perform that calculation, you'll get the value as 0.3011. Meaning of that is this value, value of P over 2, this area is 0.3011. This is 0.3011. You can label that. Let me try to show that here. This is equal to 0.3011. And this is also equal to 0.3011. So once you have this area, if we add those two areas, that is your p-value. So in next step, we can write the p-value. So p is equal to 0.3011 plus 0.3011, which is equal to, if you add that, it is 0.6022. We get the p-value. And you know that in order to reject the null hypothesis or reject the claim, we have to compare this p-value with alpha. You can see here p-value is 0.6022 and alpha is 0.05. That is, this is greater. So you have p is greater than, this implies, let me write here, p is greater than alpha. So you know that when p is greater than alpha, we fail to reject null. We fail to reject null. Fail to reject the null hypothesis. Okay, so meaning of that is we are not rejecting the null. We fail to reject null. Instead, we reject the alternate. We fail to reject the null. We are not rejecting the null. We are accepting the null. We are rejecting the claim. Our question was, now if you go back before we write the conclusion, the question was, is there enough evidence to reject the claim? We are rejecting the claim. Yes, there is enough evidence to reject the claim. So our conclusion is, yes, there is enough evidence to reject the claim. There is enough evidence to reject the claim. Okay. Testing the difference between two means of independent sample using t-test. So again, we are testing the difference between two mean, but in this case, we are using the t-test. Let's see what we need to know. Your sample must be random, that is first thing. And then the sample size, okay, sample size are less than 30 and population must be normally distributed. That's another condition. But the very important and key here is the population standard deviation, it is not known, okay? The population standard deviation are not known, but the sample standard deviation are known. So you don't know the sigma, instead you know the S. So you have S1 and S2 instead of sigma 1 and sigma 2. So when you look at the formula here, the formula is very similar to the last formula, but we have S, that is the sample standard deviation for both samples. That's why this value is a t value. And you know that whenever we are working on the t distribution, we need the degrees of freedom. But here we have two samples. The sample size can be N1 and N2. So if you want to know the degree of freedom for the first, it will be N1 minus 1. Degree of freedom for the second will be N2 minus 1 because it is N minus 1. So there are 2 degrees of freedom here. So which one to choose? The idea is pretty simple. You find these 2 values and the degree of freedom is smaller of these 2. Okay, whichever is smaller of these 2, that will be your degree of freedom. So that is the key here. This is very important. Your degrees of freedom, df, is the smaller of n1 minus 1 and n2 minus 1. Whichever is small, that is your degree of freedom. So make sure you highlight that formula, note the degrees of freedom, and we are going to use this formula to solve the hypothesis problem using t-test. Here is that example. It should not be very difficult now. Example, a random sample of teachers from two different schools are collected to study their average salary. The table below summarizes their statistic. There is school A, there is school B. For school A, sample size N1 is 15. So if you want to label that in the note catcher, we can do this. This is N1. Sample size for second school is N2. Average salary X1 bar and X2 bar. Similarly, the sample standard deviation S1 and S2, because this is the standard deviation for school A and school B. So they are for the sample. So that information is given to you. Now the question is there a significant difference in teacher salary between two schools at 5% significance level? So let's write the hypothesis here, because we are testing the significance difference. So in the solution, first we write the hypothesis. So always remember, in null hypothesis for two sample test, here we are talking about mean. So mu1 is equal to mu2. That's your null hypothesis. Alternate hypothesis, we are testing the significance difference. Also, this is our claim because we are checking this. Is there a significance difference? So that is our alternate hypothesis. Mu1 is not equal to mu2. That is the claim. That is the claim. So once we have the hypothesis set up, we'll be able to determine whether this is one tail or two tail test. Clearly, you can see there is not equal to sign. Meaning of that is this is two tail test. Two tail test. So meaning of that, your p-value lies on the two tail. This one and also here. So the value over here is p over 2. The value over here is p over 2. And also what you know is, because the sample standard deviation is given, this is the t distribution. So the value over here, if this is positive t, the value on the other side should be negative t. So this graph shown here is t distribution with, we need the degrees of freedom. If you look here, the first one is 15. So the degrees of freedom n minus 1 will be 14. And this one will be 30 minus 1, 29. So the small will be 14, because we have 14 and 29 to compare. 14 is the smaller, so the degree of freedom will be 14, with 14 degrees of freedom. So we have the t distribution with 14 degrees of freedom. Now what you know is, we need these t values, and by using the t values, we need to find this total area, the sum of these two areas. What is this p over 2 equal to? We need that. So what do we do? First, we are going to find the t, or the test statistic. So let's do that. We have, let me write that formula here. We have the t value. Okay, let me write it little nicely. It's not looking good. We have t equal to, let's write that formula, x1 bar minus x2 bar minus mu1 minus mu2 divided by, inside the square root, you have s1 squared over n1 plus s2 squared over n2. Okay. So this implies, let's simplify this, t is equal to x1 bar minus x2 bar, that is the difference of these two, which is 35270 minus 29512 minus mu1 minus mu2, these two are equal, so that is 0, divided by the square root of the first standard deviation, 3256 squared over the first sample size 15, plus second standard deviation 1432 squared over sample size is 30. Now we need to simplify this using calculator. Make sure you put parentheses in the numerator so that you will get the correct result. And after simplification, you should get 6.5401. 5401. That is your t value. That means this is 6.5401. This is 6.5401. Okay, that should be the t value, the test statistic. Now, let me write the calculation. Now your p value is 2 times this area, but this area is given by TCDF. It is TCDF in your calculator. Lower limit here is negative infinity, so negative E99. Upper limit is, this is negative value, so negative 6.5401. And then we need the degree of freedom here. We have 14 degree of freedom, 14, which is equal to 2 times. So if you use your calculator, let's see what we get. So this is what we get from calculator. Now, if you multiply that by 2, you'll get the total area. So this value here, this is just this one, area on the left and area on the right. So if you double that, you'll get the p value, which will be 0. Now you'll have 4 zeros, 1, 2, 3, 4 zeros, and then 14. 7 times 2 is 14. So that's your p value. And you know that in the hypothesis testing, we compare this p value with the significance label. Here we are looking at 5% significance label, meaning of that is alpha equal to 0.05. So if you try to compare, you'll see that your p is less than alpha. You get p less than alpha. And you know that if p is less than alpha, we reject the null hypothesis. So you can write that we reject null hypothesis. We reject null hypothesis. Meaning of that is we reject this, we support this. So we reject the null hypothesis and we support the alternate hypothesis. And alternate hypothesis has the claim. So is there a significant difference in teacher salary between two schools? The answer is yes. So there is enough evidence to support the claim at 5% significance label. So we can write that conclusion. There is enough evidence, let's write that. There is enough evidence to support the claim. Support the claim that there is difference. There is difference in teacher salary at two schools. At two schools. Testing the difference between proportions. So what you need to know before we talk about the proportion. So if you look at first two examples, we talk about the mean. So when we're talking about the mean and the population standard deviation is known, we use z-test. When we are talking about mean and population standard deviation is unknown, we use t-test. Now we have the third one, proportion. In proportion, we use the z-test. Same concept as we have seen last time. The sample must be random. The samples must be independent because we are talking about P and Q. N times P and N times Q, 1 minus P is Q, must be greater than 10. And if we are not using calculator, the test statistic is calculated using this formula. You can see here we have P1 hat, P2 hat, that is the sample proportions. And these are the population proportions. N1 and N2 are the size. And here you'll see P bar and Q bar. P bar is given by this formula here. And then Q bar is 1 minus P bar. But what I'm doing is, instead of using this formula, I'll be using TI-84 calculator to get this test statistic. Let's see whether that will be easy or not. Let's take an example. Example, a survey of 60 students at CCA found that 36 own house. Another survey of 50 students at CCD found that 28 own house. At alpha equal to 0.05 or 5% significance level, is there a difference in proportion? That's what we need to check. So let me write the information here so that it looks a little beautiful. Here the survey is conducted at CCA and CCD. So two group of samples. At CCA, you surveyed 60 students. So your N1 is equal to 60. And you found that 36 own a house. So your X1 is 36. Similarly, you have the another survey at CCD, which is 50 students. So N2 is equal to 50. And then your X2, 28 of them, they have a house. So X2 equal to 28. So this is the information given in the problem. Now what we need to do is we need to check if there is a significant difference in the proportion. Now let's set the hypothesis. I'm setting the hypothesis. Null hypothesis, as I said, it is P1 is equal to P2. If it is mean, mean 1 is equal to mean 2. But here we are talking about the proportion. So first proportion is equal to second proportion. But the alternate hypothesis is we are checking if there is a significant difference. So it is P1 is not equal to P2. And we want to check this. So suppose this is my claim. That is my claim. And because we have equal to sign here, this is the two-tail test. Two-tailed test. So here in this distribution, your areas are on the two-tail. So area is on the left tail and also on the right tail. So this is the area, this total area on the left plus total area on the right. If we add these two, that will be your p-value. So if I add this area and this area total, that is your p-value. P equal to how much? And also these values here, because we are using the proportion, these are the z values. So this is z and negative z. So you know that if we are using formula, first we have to find these z values. And then using those z values, we have to find the p-value. But here, what we are going to do is, instead of using the formula to find the z and the p, we are directly using our TI-84 calculator. Let's do that now. So what we do is, in order to perform this test, we go to stat here. You can see stat. Go to stat. We are doing the test. So scroll horizontally to test. That's your test. And then we are talking about the two sample proportion. So we have two samples, CCA and CCD. Okay, and we are talking about the proportion, like out of 60 students, 36 have a house at CCA. And out of 50 students at CCD, 28 have the house. So we're talking about the proportion, and it's going to be the Z test. So we are going to select number 6. There we go. Then what we do is we plug in the information. X1, we have 36 if you look at your notes. 36. N1, the first sample size is 60. Then X2, if you look at X2, it is 28. 28 of them have house. And we took a sample of 50 students at CCD, so that's 50. Here, you have to select the proper sign for the alternate hypothesis. If alternate hypothesis has a greater than sign, we select this. If it has less than sign, we select this. If it has not equal to sign, we select this. In our case, we have not equal to, we select that. Then if you want to look at the drawing, if you want to see the drawing, you can go and click here. It will even give you the drawing. Let me show you the drawing first, how the graph will look like. Let me draw that. Okay, just wait there. See, that is the graph. And when you draw the graph, you can see the z value and also the p value. So your p value, you can copy that in your notes. You can see that your p value is 0.6719. That's your p value directly. And the z value is 0.4235. 4235. So from calculator, we got the p value and we got the z value. The positive z value is this one. So the negative z value is negative 0.4235. So once you have everything labeled here, once you have the p value, we compare this p value with alpha. So you can clearly see your p is greater than alpha. P is greater than alpha. And you know that if p is greater than alpha, what we do is we fail to reject the null hypothesis. Let's write that down. Fail to reject the null. We fail to reject the null hypothesis. We fail to reject, meaning of that is we are not rejecting the null. Instead, we are rejecting the alternate. We are not rejecting the null. Instead, we are rejecting the alternate. That means we are rejecting the claim. Meaning of that is there is not enough evidence to support the claim. That's what we are going to write. Let's write that down. There is not enough evidence to support the claim. We are not supporting the claim that there is no difference, because we are checking, is there a difference? That there is no difference at 5% significance level. So that is the conclusion. You can see that in this example, we use our TI-84 calculator to perform the calculations to find the z value and also the p value.